This is going to be a lot of fun because I'll have none of you here to interact with me, which is exactly why I became a teacher, was so that I could be around no students. I miss you guys. But even though we can't be in the same classroom, I still want you to learn math. So 8.5, or should we start with 8.4? I think 8.4 is a review. Yes, 8.4 is a review. Does everyone have their review notes out? This is a work day, so I'm going to essentially just give you the answers and maybe do a couple of problems from this review. And then for homework, you have homework 8.4, which is, again, nothing new. Just making sure that we really understand how to simplify, multiply and divide, and add and subtract with rational expressions and complex fractions. So, on this review, number 1 and number 2, simplifying, I got 3x over x minus 1. Number 2, I got 2n minus 3 over n plus 9. Number 3, I got a minus 3 over a plus 4. And number 4, I got a negative 8y squared over y minus 3. Number 5, I got w plus 9 over 4w minus 1. Now let's do number 6. We'll do number 6 together. So here are your answers for 1 through 5. If you are getting these, you are on the right track. So keep up the good work. Number 6 says 30c cubed minus 60c squared all over 3c. And then it says divided by 2c cubed minus 16c squared plus 24c. Okay, please recognize that if you only have one term, this is the same exact thing as if I say over 1, right? Because if you divide anything by 1, you're left with the same expression. So what I'm going to do is I'm going to start factoring these things out, and then remember, when you're dividing rational expressions, you need to multiply by the reciprocal. So I'll flip this on its head. So I look at this top term. Looks like I can pull out a 30c squared, and I am left with c minus 2. Again, you can always double check by redistributing this term back into both the terms and making sure you end up with your original expression over 3c. And then I'm going to multiply by the reciprocal now of this, and I'm also going to factor this one. So it looks like I could take out a 2c, and I'm left with c squared minus 8c plus 12. This can be factored one step further, so I get 30c squared times the quantity c minus 2 over 3c times 1 over 2c times, if I factor this expression, I'm looking for factors of 12 that will add up to be a negative 8. So that could be a negative 6 and a negative 2. Negative 6 times negative 2 is a positive 12. Negative 6 minus 2 is a negative 8. Bingo. So now I'll just double check that everything is being multiplied together, and it is. Multiply, 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 multiply. If everything is being multiplied together, you are allowed to cancel out terms. So this c minus 2, I'm going to cancel out with this c minus 2. This 3c I'm going to cancel out, and this becomes a 10c. This 2c is going to cancel out, and this will become 5. And it looks like that is all I can do. So if I look at everything on the top, trying to make sure I don't forget something that I didn't cancel out, looks like I'm left with a 5 on the top, and on the bottom, just c minus 6. Boom, done. Okay, 7 and 8, this is starting adding and subtracting. For both 7 and 8, they already have a common denominator, so you're allowed to just do the expression in the numerators combining like terms, and then simplify from there. So for 17, did I say 17? I mean 7. I ended up with 5 halves once I simplified completely. And for 8, please remember that that negative in between your two rational expressions, you have to distribute to both the m as well as the 28 in your problem. So if you do that, and then you notice that there is a square difference of perfect squares in the denominator, and cancel those out, you will end up with an 8 over m plus 5. Woo, we're flying. Okay, let's just randomly choose what we want to do here. Let's do number 9 out. So number 9 does not have a common denominator. We have 3 over 12y plus 9 over 24. So you need to, wow, that y, there we go. To get from 12 to 24, I have to multiply by 2. Remember, I have to do 2 over 2 because I'm not allowed to multiply by something that's not by 1. So if I do that, I end up with 6 over 24y. And now plus, when I look at what is missing between 24 and 24y, what is missing is the y over y. So I end up with 9y over 24y. Now that you have a common denominator, you're allowed to do the numerical operations in the and now I don't know if I messed up. Did I say numerator the first time? And we don't know because none of you all were able to giggle at me. So now that I have a common denominator, I'm allowed to do the mathematical operations and combine like terms in the numerator. So if I do that, I end up with 6 plus 9y all over 24y. This can definitely be factored, and I am not stalling for time when I think about what goes into all of these as a 3. So I'm going to pull out 3, and I get 2 plus 3y all over 3, 8y. The 3's will cancel, and then I am left with a 2 plus 3y all over 8y. And that is reduced as much as I can get it. For 10, I got p minus 5 all over p minus 9. Please remember to factor the denominator of that left-hand side to see what the right-hand side denominator is missing. For number 11, I got the quantity r minus 3 times r plus 2 all over r times the quantity r plus 6. And unfortunately, that can't factor and reduce any further. For number 12, I got 8h minus 25 all over h minus 5, h minus 2. Woohoo! Okay. Let's wrap up this review with a few complex fractions, and we will call it good. So for 13, we get a 15x minus 10 all over x minus 8 all over 3x minus 2 all over x squared minus 12x plus 32. Now remember, for these we went into why you're allowed to do this when we first did this lecture, but for a review, remember, if you have a single rational expression over another single rational expression, you're allowed to take the bottom and then go ahead and multiply by its reciprocal on the top. So this will become times x squared minus 12x plus 32 over 3x minus 2. Now if I did this and then I did it over itself over 1, that's how you can see that this denominator rational expression would cancel itself out. So now that I've got that, I'm going to factor and try to simplify just like we've been doing. So I can take out a 5 and I'm left with 3x minus 2 all over x minus 8 times factors of 32 that will add up to be a negative 12, negative 8 and negative 4 all over 3x minus 2. Now I'm pretty happy because the x minus 8 terms will cancel, the 3x minus 2 terms will cancel, and I am left with a single answer of 5 times the quantity x minus 4. Let's double check it. Yes. Okay, number 14, you should end up with a negative 7 over 1 plus m. The key here is that you need to combine the numerator before you're allowed to do the multiplying by the reciprocal of what the denominator is, because the numerator in this problem is two different terms. So you need to find a common denominator and combine those before you're allowed to do that. Let's do that. Well, actually, let me write down 15. 15 is the same way, and you should end up with 2 times the quantity p plus 10. And now let's do number 16. So if we look at number 16, I have 4v over v minus 1 over v squared all over 1 minus 1 over 2v. So if I look at this one, I need to combine this into a single rational expression as well as this into a single rational expression. So if I look at just the top for now, the denominator here is a v squared, which means that this is missing a v. So I'll do v over v. If I look at this, 1 is the same thing as 1 over 1. Groundbreaking, I know. It's missing a 2v, so I'll have to multiply that term by a 2v over 2v. So when I do that, my denominator here becomes a v squared. So I'm allowed to just write that. My numerator becomes a 4v squared. And then minus, and this is a 1. Nice. Here, this denominator becomes a 2v, which matches this. So I'm allowed to just write that. And then I get 2v minus 1. 2v or not 2v? Oh, I hope school starts back up again after spring break. Okay, now, single rational expression over a single rational expression. I'm allowed to take this, flip it, and use multiply by its reciprocal up here. So I'm going to do that. I get a 2v over 2v minus 1. And now I can get rid of that. So now if I factor this, 4v squared minus 1 is a difference of perfect squares. The perfect square of this term is a 2v, and 1 obviously is 1. So I'll end up with a 2v minus 1, a 2v plus 1, all over v squared, times 2v over 2v minus 1. Those ones are already as simplified as they can be. So this 2v minus 1 cancels out with this 2v minus 1. This v will cancel one of the v's here, and I'm left with just a single v. So it looks like I'm left with a 2 times a 2v plus 1 all over just v. Okay. Great, the homework assignment related to this review is homework 8.4. And it is due on Friday with everything else. But please go ahead and don't save it till the last minute. If you have questions should be dealt with either in the comment section of the video or on Google Classroom. What I'm gonna do is look through all the comments as y'all are working, because obviously I can't have office hours. And if you're the only one with the question, I'm not gonna answer it. Just kidding, just saying if you're paying attention. I will answer it, of course, but I'll probably just email you. If a lot of people are having the same types of questions, then I will probably just post another video that's going to hopefully address all the confusion all at once. So it's really important that I'm getting that feedback, because since you're not here in class, I don't know what's making sense and what's not making sense. And guess what? You guessed it. We're graphing reciprocal functions soon, and that could be confusing. So again, please just reach out to me if you have questions. I want you guys to still hopefully get this stuff down and feel confident.